Hello everyone, welcome to May's Adventure. I'm Yusra Shah and these are my teammates Sadia Fatma and Abdul Qudus. I want to tell you something important about how we built this. We didn't just split tasks and work separately, we actually developed this through 15 incremental versions, each person building on what the previous one created. It's how real software teams work in the industry. So, what is Maze Adventure? It's a game where you're trapped in a maze, trying to find a key and escape while an intelligent enemy hunts you down. Every maze is completely unique because we generate them using algorithms, specifically DFS and BFS. What makes this special is not that it's not just a game, it's a showcase of everything we'll learn in data structures and algorithm class, actually working together in real time. Now let me tell you about our journey. Sadia was the brave one who started from nothing, version 1, the first prototype. She had to figure out maze generation, Java swing graphics, everything from scratch. That's the hardest part, creating something from zero. Then Kudus took it forward through multiple versions. He added the enemy that chases you using BFS, made the mazes better, threw in traps and treasures to make it exciting, and created all those beautiful animations and particle effects you'll see. My role came in later versions. I said, okay, we need difficulty levels, so I split the enemy AI into easy, medium, and hard modes where the enemy gets smarter. Then I thought players should be able to save their scores, so I built the entire MySQL database system, registration and login, leaderboards, and everything persistent. But here's the thing, we all touched each other's code constantly. I fixed bugs in the maze generation. Abdul Quddus improved my database queries. Sadia refined the UI. That's real teamwork. So, what was our vision? Our vision was simple, create something that's technically impressive but also genuinely fun to play. We wanted something smooth animation, intelligent AI that adapts to difficulty, and a professional look. It doesn't feel like a student project. And honestly, I think we achieved that. Now, let me show you how the game actually works. Watch how smooth everything is. This is the login dashboard. This is the first thing you'll be saying when you execute the game. And I have to enter my name here. If you are a new user, you have to register for using the register button. And if you are already registered, so you have to enter the login button. So first I'm gonna register with a new name, I guess. Let's call it something like ABC. And if I try to log in, there will be error showcase because I'm not registered. So I have to register first. And after registration, I will automatically will be logged in. But I have to show you some other things, so I will be registering it as my own name, and I will start with my name. Actually, we have put in the both action listeners, the keyboard one and the mouse listener. So if you actually press the button login, you will be able to log in, but you don't have to do that. You can just click the enter key and you will be automatically logged in. So in the main menu, this is the main menu dashboard. There are three buttons: start game, leaderboard, and logout. The leaderboard button shows us the leaderboard. Let's see it. This is the information fetched from the MySQL database. The higher the score, the upper the person on the dashboard. The three trophies for first, second, third. The first for the golden one, silver second, and the bronze one for the third. And let's see, let's go back and start the game. So this is the levels dashboard. Actually, there are three levels for the easy, medium, and hard. I hope you're listening to the background music. We have put a lot of effort in it. Let's start with the easy one. This is the easy mode of the game. Let me introduce to our protagonist, the hero or the user. This is the one in blue, and this is the one in the red is the enemy. Actually, this is the maze. It is auto-generated. So let me just introduce the components of the game. The red one's the traps, and the chest component you see is a treasure. Each treasure holds 10 points, and there are total 3 lives for the player. And if player encounters the enemy or the traps 3 times, he will lose the game. But if he gets to the key, right, shown here, and to the door, which will appear after we get to the key, the player will win. And there are two types of movements in here. We can either move by the AWSD keys or the arrow ones. I will use the arrow ones for my convenience. Let's see here. Let's just first win this game, then we will lose. I can show you the effects later. Let's just move. As you can see, as a player moves once backwards, the player moves. One step from the player, one step from the enemy. Two step from the player, two steps from the enemy. Let's encounter a treasure and get those 10 points. Yep. Let's get the tree key and we get the door has appeared. Now we have to get through the door. This is the easy mode, so let's just lose that 2 lives. And we lost 2 lives. I think we are going to get trouble with the enemy, so let's just move back. As you can see, this is the easy mode, so there are multiple paths to get to the same destination. We got the door and we actually win. Congratulations. If you want to play again, you can just click the yes button and the maze will be generated uniquely afterwards. And if you're not satisfied with the maze generation, you can actually click the R key and you will be able to see the new maze each time. Just as you see the R key. Let's just press escape button on. We can just go back and let's start with the medium one. Main menu. Yes. Let's start the game again, but this time with the medium. This is the medium difficulty level. So there will be less paths and more traps and more difficulty. Let's just move. Why don't we lose this one? As we go, we just lost 1 life. But we got to the door appeared. But let's not go to the door, let's go to the enemy. And the enemy cost us 1 life. As you can see, it's much smarter than the easy mode. Let's just encounter it one more time. And did you notice when we actually started from the first initial point. That's the unique thing about that. But the enemy remains same, so that's pretty tricky. That's what makes it fun. And we are able to trick this one now. Yep, we tricked this one, but we are ended up in a loop because each time the enemy takes one step, the player gets also. Let's just run from this one. I guess we are meant to we are meant to win. Let's just win this one also. Yep. So just let's go back to the main menu again. And let's just start with the game. Let's go hard this time. This is the hard one. Let's try to win. Actually, we're gonna get defeated because it's the right one. Let's see what happens. Okay, as you can see, they're not much very fast. It is very congested. A lot of traps around the key. Uh-huh. Lots of them. We actually got killed. Only 1 life is left. The door is found, but we actually lost. No, no, you don't want to play again, so bye. And about other functionalities, even if you go in the start game and you press the escape key, you will see a menu like this. And even in the main menu, if you press the escape key, you you will get a menu like this. So this is the game. How do you like it? I hope you have fun. Technology wise, we kept it practical Java because it's what we know best. Swing for the graphics and MySQL for storing player data. We use prepared statement to prevent SQL injections because security matters even in student projects. So let's get uh, familiar with the database. We use MySQL database. This is the actual database. We named the database as project 3 and we created a table through commands. And let me just show you the table. This is the table and which the user is fetching the data from. As I played the game earlier, the score has updated, and as the players score updates, the positions vary accordingly. Now let me just demonstrate the database code on an abstract level. I first imported the java.sql library to make these functions feasible. Then I created a connectivity class. As you can see, it's just above everything else code. It's a connectivity class because it was a main element, and we are storing, and its method connecting database is used everywhere. To make it work, I actually imported the JDBC driver for MySQL. We have to actually download it and use it in our environmental variables according to the class path. And this is the project 3. You actually have to put the password here and your username. You must have the MySQL workbench and password here, as I have put mine in here. After we have made the driver manager and everything connection based, there is every little error handling in this method. The basic connection oriented and also keeping things private by the private variable. Let me just show you some queries. Like this one, select user ID from it is to demonstrate the leaderboard. I have actually used the prepare statement, as you can see from the question mark. It is a prepare statement, not the connecting statement, because it prevents SQL injections. Student projects also need security, not vulnerabilities, and that's it. We have used them at different parts to make queries and feasible. Like new user, we insert it into the game table, as I showed you already. Still using the prepare statement, and so it's the first time, so the score will be 0 and the number of lanes game will obviously be 0. That's it for now.
So this is Sadia Fatima, and I'll explain the core data structure logic behind the maze adventure game. So this module is responsible for the maze generation, shortest path discovery, and counting all the shortest paths that exist in this. I'll walk through the logic step by step, focusing on how DFS, BFS, and dynamic programming are used together. So here, let us begin with the initialization of the grid. Every cell begins with fully closed all four walls intact, and all flags such as visited, trap, treasure are reset. This guarantees that maze generation always starts from a clean and predictable state. After that, let us begin with the maze generation using iterative DFS. So maze generation is implemented using an iterative depth first search with the backtracking. We begin with at the top left cell and push it onto a stack. And at each step, we collect all the unvisited neighboring cells, and one neighbor is selected randomly. The wall between them is removed, between those two cells are removed, and the neighbor is pushed onto the stack. After that, if a cell has no unvisited neighbors, we pop the stack and backtrack. This process continues until the stack is empty. And this algorithm guarantees a perfect maze, meaning the maze is fully connected and contains no cycles. After that, let us begin with the wall removal logic. In this, the remove wall function determines the relative position of two adjacent cells and removes the corresponding walls from both sides. And this ensures the movement between cells is like between the cell that they are consistent and the bidirectional. After that, let us move forward with the BFS shortest path. So once the maze is generated, we use the breadth first search to find the shortest path. BFS is ideal here because the maze is unweighted. So the first time we reach the target, we know the path is optimal. So a queue is used to explore the cells level by level, while a parent array tracks where each cell was reached from. So after reaching the destination, we reconstruct the path by following parent pointers back to the source and reversing the result. So here, that's the last part, the जो मेरा है, counting the shortest path, which is a bit advanced part. So this method calculates how many distinct shortest paths exist between the start and the target. First, BFS is used to assign every cell its minimum distance from the very start. Then, using dynamic programming, we process cells in increasing order of distance, and each cell passes its path count only to neighbors that are exactly one level deeper. So, this approach efficiently counts all the shortest paths without rerunning the BFS technique multiple times. So, to conclude, this module integrates DFS for maze generation, BFS for shortest path discovery, and dynamic programming for path counting. So, the result is a clean, scalable, and algorithmically sound maze engine suitable for interactive gameplay.
So let's start with GUI architecture overview. A graphical user interface of the Maze Adventure project is implemented using Java Swing and Java FX. The design follows separations of concerns where game logic such as maze generation and pathfinding is kept separate from the rendering and the user interaction logic. This makes the system easier to maintain and to extend. Main GUI components. The main window is implemented using a JFrame which serves as a container for all the components. A custom JPanel is used to visually render the maze grid, walls, and players' positions. Interactive elements such as buttons allow users to start the game, generate the maze, or trigger path finding. Event handling and user input. User interface is handled through event listeners attached to buttons and keyboard inputs. These events update the game state, such as moving the player or triggering algorithms. The GUI responds instantly, providing real-time visual feedback. Sound integration. Sound effects are integrated to improve user experience. The different audio clips are played for events like player movement, winning the game, or triggering the traps. This auditory feedback makes the gameplay more engaging and interactive. Now let's come to the part where we use software engineering in our own project. Code. So the first principle that we used was code modularity and code organization. The project is structured into a modular components where each class has a clear responsibility. This modularity improves readability, simplifies debugging, allows the future enhancement without affecting the entire system. Scalability and extensibility. New architecture is designed to be scalable. New features such as additional levels, AI players, or advanced scoring system can be added with minimal changes to the existing code. Thank you for teaching us and helping us to make such a great game. Thank you.